Hello students, in last session up to the example number 13 completed. Now we discuss example number 14 from our textbook. See the question on a page number 149 in your textbook. Whenever see your e-learning session, please take your textbook with yourself. Example number 14 in a textbook on a page number 149. O is any point inside a rectangle ABCD. See figure 6.52. One figure is given. If the figure is not given, it is easy to draw. Prove that OB square plus OD square is equals to OA square plus OC square. O is a point inside a rectangle. First of all, we have to draw one rectangle. Rectangle is A, B, C, D. O is a point inside it. Let's take point O. Inside it, we need to prove that OB square plus OD square is equals to OA square plus OC square. Given a rectangle, ABCD, in which O is point inside it, we need to prove that OB square plus OD square is equals to OA square plus OC square. First of all, we have to join O to A, O to B, O to C and O to D. Let us join OA, OB, OC and OD. Now we draw one line passes through point A parallel to BC and AD. Draw line PQ passes through O and parallel to AD and BC. You should also try to drawing line parallel to AB and CD is also possible. Now the three lines AD, PQ and BC are parallel. AD parallel to PQ, parallel to BC. That's why these two angles are 90 degree. Four angles are of a 90 degree angles, as well as AP is equals to DQ and PB is equals to CQ. It is our result number 1. Now we have to apply 4 times the Pythagoras theorem. First of all, apply Pythagoras theorem in right triangle OPB. In right triangle OPB, using Pythagoras theorem. Square of hypotenuse OB is equals to OP square plus PB square or BP square. It is our second result. Now same way, for the OD, we have to use triangle ODQ. In right triangle ODQ, using Pythagoras theorem, hypotenuse is OD, square of OD is equals to OQ square plus dq or qd square, which is our result number 3. Now same way for the OA, use triangle OPA. In right triangle OPA, using Pythagoras theorem, the square of hypotenuse OA square is equals to AP square plus OP square, which is our 4th number result. Now the last triangle OC, means in triangle OQC, in right triangle OQC, using Pythagoras theorem. The hypotenuse is OC. OC square is equals to OQ square plus QC or CQ square. CQ square, which is our result number 5. Now, first of all, we have to take left hand side of proof. Left hand side is equals to OB square plus OD square. But we know OB square is equals to OP square plus PB square, OP square plus PB square, and instead of OD square, OQ square plus DQ square. Reason is from 2 and 3. Now, to obtain OA square plus OC square, OA square plus OC square required AP and OQ. AP and OQ. OQ is already here. OQ is already here, but we don't require OP, so that we have to replace it. Again we required OP for the OA, because OA square contain OP square and the OC square contain OQ square. We don't know PB square and DQ square. Now we replace PB square with CQ square, OP square as it is, plus instead of PB square, which is CQ square, we required CQ square here plus OQ square as it is, and instead of DQ square, which is AP square. Our reason is because of PB is equals to CQ and AP means the DQ is equals to AP. From 1, it is reason to change. Now make a pair. For the OA square, we required AP square, OP square. AP square, OP square, put it into bracket. AP square plus OP square plus remaining into the bracket OQ square plus CQ square, OQ square plus CQ square. But instead of AP square plus OP square, which is OA square, and instead of OQ square plus CQ square, which is OC square, but it is our right hand side, hence left hand side is equals to right hand side. Is proved. Hence the proof of example number 14 is completed. Now we discuss another one. Next is our exercise 6.5 from a textbook. Exercise 6.5 on a page number 150. First of all, see the question. Sides of triangles are given below. Determine which of them are right triangles. In case of right triangles, write the length of its hypotenuse. There are four different sides of triangle is given. Question number 1. In the first one, 7 centimeter, 24 centimeter, and 25 centimeter. First of all, we have to take square of all sides. 7 square is equals to 49. Square of 24 is equals to 576, and square of 25 is equals to 625. What happened here? Here, the square of two smaller sides, 7 square plus 24 square is equals to 49 plus 576 gives us 625. It is the square of greater side. The square of two side is equals to square of one side. Using our theorem 6.9, square of one side is equals to sum of the squares of another two sides. Then the one angle is right angle. Here, square of one side is equals to square of is equals to sum of square of another two sides, so that using converse of Pythagoras theorem, given sides are of right triangles, it is a right triangle. And write the length of hypotenuse. Now it is right triangle, length of hypotenuse is larger side is hypotenuse 25 centimeter. Now we see the next second number. The second number is 3 centimeter, 8 centimeter, and the 6 centimeter. First of all, do the square of all three sides. Square of 3 is equals to 9. Square of 8 is equals to 64, and square of 6 is equals to 36. Now take the squares of addition of two smaller sides. Here, square of 3 plus square of 6 is equals to 9 plus 36 is equals to 45, does not equals to the squares of another side, which is 64. Therefore, it is not right triangle. So the length of hypotenuse doesn't obtain here. Now the third number. Third number is 50 centimeter, 80 centimeter, and the 100 centimeter. Do the squares of all three sides. 50 square, 2500, square of 80, 6400, and square of 100 is equals to 10,000. So obviously here the square of 50 plus square of 80 does not is equals to square of 100. Here, square of 50 plus square of 80 is equals to 2500 plus 6400 is equals to, do the addition, doesn't equals to 10,000. Therefore, it is not right triangle. Now the next fourth number, 13 centimeter, 12 centimeter and 5 centimeter. Do the squares of all sides. Square of 13 is equals to 169. Square of 12 is equals to 144 and square of 5 is equals to 25. Addition of two smaller squares of two smaller sides. Here square of 12 plus square of 5 is equals to 144 plus 25 is equals to 169. It is a square of 13. Yes, here the square of one side is equals to sum of the squares of another two sides. Here, using converse of Pythagoras theorem, square of one side is equals to sum of the squares of the another two sides. Therefore, it is right triangle. If it is right triangle, in which we have to say the length of hypotenuse. Therefore, length of hypotenuse is the highest side 13 centimeter, which is 13 centimeter. Now we discuss the next number from the exercise. See the next question number 2. From the same exercise 6.5 on page number 150. PQR is a triangle right angle at P and M is a point on QR such that PM perpendicular to QR. Show that PM square is equals to QM into MR. PQR is a right angle triangle. First of all, we have to draw one right triangle in which right angle at P, PQR, P is the right angle, M is a point on a QR such that PM is perpendicular to QR. In right triangle PQR, angle P is equals to 90 degree, PM perpendicular to QR. We need to show that, means we need to prove that, PM square is equals to QM into MR. First of all, we have to use theorem 6.7. According to this theorem, take a one acute angle from Q, go to the right angle side, means take name of triangle QPR. Same way from Q go to right angle side and go to again right angle side. PM square, so that we have to take two smaller triangles. In triangle QMP and triangle PMR. Triangle QMP is similar to triangle QMP, similar to PMR, because of theorem 6.7. That's why take the ratio of the side. MP means the PM corresponding to MR is equals to, next is also PM corresponding to QM upon PM. Reason is sides are proportional. Therefore, square of PM, do the cross multiplication, is equals to QM into MR. Hence proved. The question number 2 is completed here. Now whenever we meet in next session, we discuss our question number 3. The question number 3 is also depends on question number 2 as well as the theorem 6.7. If you have any query regarding homework, regarding sum from our textbook, please tick mark it very well.